Okay, welcome to how to run cluster analysis using Excel. This will be looking at k-means clustering. Okay, step one, start with your data set. For this example, I'm just using 15 cases, 3 variables as you can see. So you've got to have your data outlined nice and neatly. I'll talk about what these start points are in a second. If you're only using 2 variables, then you can use a scatter chart to just map it out. I've created this one by utilizing the first 2 variables only, and then I've had a look at it and I've drawn these circles on. These are not from the graph. This one here I've plotted. That's the average of all the variables, and I'm just showing you that initially there appears to be some clustering evident. However, because I'm not using 2 variables, I'm actually using 3, a visual check or a visual clustering approach is not going to work because I'm not going to factor in the 3rd variable. Possibly you'll have more than 3 variables, so this is just a starting point. Okay, step 3 is we need to work out distances of each of these cases. Now the way k-means clustering works, if I come back up here, we have to have some random starting points. Now the way I prefer to do it is what I've done for each variable. I've done minimum, maximum, medium. I want to use 3 starting points because I want to form 3 clusters. So what I do, I can pick any of these randomly, but what I prefer to do is make sure they're spread out a little bit. So I'm using the x variable only, and I've picked the one with the minimum score, which is case 15, and I'm calling that start 3, and then the maximum is case 9 here, and the median is start 1. So what I then do is for each one, and I'll show how it works here, I work out the sum of the square difference. So for each case, when I start at case 1, what is the distance between it and start point 1? Now start point 1 I've just designated as case 6. I've randomly picked that as explained. And all I go through is, and you can see the formula there, what's the difference between each of the variables. Then I just square them, and then I sum them. Okay, and I get that number there, 1054. That's a fairly mechanical way of doing it. Much more efficient way of doing it is to use that particular calculation there. Okay, so you can see in the formula, I'm not doing it this way, I'm actually using that, and I'm summing case 1, which is in those cells, and I'm using a label start 1 up here, that data there, I've just labeled that, named that start 1. Just makes it easier when you're copying formulas, then I can just copy that formula down because they're fixed addresses and that stays the same, so that just gets copied down. Okay, as you can see, case 6, 9 and 15 are my starting points, so when they marry up to their actual start points there is no difference, they're exactly the same. Then I go through and go, okay, what's the minimum? Okay, in this one it's 4.8, which is cluster 2. So I know that case 1 is, at this point, initially, closest to the second starting point, which is this one here. So case 1 is actually the closest distance to that one there. Okay, so what I go through and I calculate the minimum of each, and then I go, okay, alright, which cluster are you the closest to? And I'm using that formula here, which I've shown you there. So it's just a series of if statements. If it's equal to 1, tell me it's 1. If it's equal to that number is equal to that, give me that number. If that is equal to that, give me that number. So that's all that's doing. It's a series of if statements. And you don't need to do this, but I just have a random check to see how many have been allocated to cluster 1, 2 and 3, just to make sure that the data is spreading out. Okay, once I've done that, I come down to step 4 and I work out where everybody is. And I'm using just a simple, again, an if statement there, which I've outlined here. So that's where it's been allocated to, so these numbers here. So case 1 is currently allocated to the second cluster, so I just want the data populating there. Case 6 is allocated to cluster 1, so basically I've just sorted out where the data sits, and then that allows me to average each of these numbers. So 4.19 is just the summary of those numbers there, the mean of those numbers there. Okay, and I just do that all the way across. What I now have, if I do that there, is that's the new mean, the revised mean for cluster 1. Initially, my mean was case 6, I just picked that randomly, but now I actually have 4 points which appears represent that cluster. So I'm changing it there, and you can see what I've done is I've got those 3 cells highlighted. I've actually renamed them there. So if you ever want to name something, you just go over the top of it and you type in whatever you want to call it and then hit enter. Okay, and I just do that because it then becomes easier to replicate formulas down here. So I've called this cluster 1, and this is our first run. So that's my thinking there. This is cluster 2 in our first run because we're going to repeat this. So that's what that means. Set it as name ranges. So what I do is then I do step 3. Remember step 3? What's the difference? Distance. So I do the same thing, but now instead of finding start point 1, I'm now comparing the same start data. So D22, if I come right back up here, D22 is case 1's variables, the information we have on case 1, and I'm now getting the distance from cluster 1, cluster 2, cluster 3, which are these things up here. So I'm comparing it to how does case 1 compare to what's in here. How's it compare to cluster 2 and then cluster 3? I'm then recalculating the difference, again working out what the minimum is, and now I'm again doing exactly the same but allocating it according to these numbers rather than just one particular case. Again, I've just got that there for information, and as you can see I now have 5, 5 and 5. Previously I had 4, 6 and 5, so one case has been reallocated across. Okay, and that's actually been case 9, which was a starting point, and that's been shifted from its starting point of cluster 2 back into cluster 1. Okay, so basically you just keep repeating this over and over until your sum of squared error, which is here, I'll show you what that is, starts to really flatten out, and each time you do the next 2 steps, recalculate it, there's minor improvement. Okay, so all that is basically the sum of that. So all that adds up to 14.35. Okay, I started at 48, so there's been a big improvement already. And basically what that is showing me is how accurate or how reflective of these clusters of the overall data set. So as you can see here, when case 6 was cluster 1, there was no distance. It was exactly the same. So the smaller these numbers, the closer these cases are to the center of each cluster. So as that number gets smaller, it means your estimation of the cluster becomes more accurate. Okay, so basically what we should end up with, we keep doing this, but I'm not going to go in the video, but you keep repeating it, you end up with, this is our starting point, or all the data mapped out without the guesses of the clusters, and now I have 3 clusters here. They're all being color coded, so blue there, diamonds, cluster 1, cluster 2 and cluster 3, and of course we can work out the mean of each and plot those individually. I have a marketing background, so I'm calling these consumers, but you can call them whatever your field of expertise is. Okay, I just need to point out something that looks weird. These 2 points here, this belongs to cluster 3, this one belongs to cluster 2, but they're basically the same point. The reason that is happening is because we are now looking at 3 variables in the analysis, whereas these graphs only look at 2. That's why this visual technique does work for 2 variables. But once you factor in the 3rd variable, there's no way of being able to do it visually. You would not pick these 2 variables here as being different clusters. So that 3rd factor variable, which is Z, obviously pushes it in a quite different direction. So that's the output you're trying to look for. I also have on the link below to cluster analysis for marketing, a template that does this automatically. So all of these graphs, etc., are automatically produced. It also gives you, again, being a marketer, segment sizes. You can change the terminology, but you can see where they sit. Those 3 circles add up to the same of these larger symbols, and how big. So there's 5 in each out of the 15. And then it also gives you an output here of the actual centers of each segment, how many allocated, etc., the error per segment, and the total error. So hopefully that helps. Visit my site for the free template.